Welcome to Solutions Chemistry Tuition. Core Principles of Chemistry. Atomic Structure and the Periodic Table. Mass Spectrometry. Topic 1. Atomic Structure and the Periodic Table. Atomic Structure. Protons and neutrons have a relative mass of 1 each. The protons and neutrons in the nucleus give the atom its mass. Electrons have a negligible, very small, mass of 1 over 1,879. Protons have a charge of +1. The protons give the nucleus its positive charge. Neutrons have 0 charge. Electrons have a charge of -1. Mass number, nucleon, is 12 in carbon. Atomic number, proton, is 6 in carbon. The periodic table is made up of 18 groups. There are metals and nonmetals. More specifically, elements fall into the S, D, P, or F subshell groups. The atomic, proton, number is defined as the number of protons in the nucleus. The mass, nucleon, number is defined as the total number of protons and neutrons. Mass number equals proton number plus neutrons. For carbon, atomic, proton, number is 6. 6 protons plus 6 electrons. Mass, nucleon, number is 12. Total 12 is equal to 6 protons plus 6 neutrons. Isotopes. Isotopes are atoms of the same element that have different masses. They have the same atomic number but different mass number. They have the same number of protons but different number of neutrons. Deuterium and tritium are the isotopes of hydrogen. What are the number of neutrons, protons, and electrons? Question. The atomic number, Z, and mass number, A, of the two types of atom are shown. Identify the atoms and give the number of protons and neutrons in the nucleus of each. Relative atomic mass. The weighted average mass of an atom of element compared with 1/12 of the mass of an atom of carbon, 12. Relative isotopic mass. Is the mass of an atom of an isotope compared with 1/12 the mass of an atom of carbon, 12. Relative molecular mass. The weighted average mass of a molecule of a compound compared with 1/12 the mass of an atom of carbon, 12. Relative formula mass. Is the average mass of the formula unit of a compound compared with 1/12 the mass of an atom of carbon, 12. Topic 2. Mass spectrometry. Principles of mass spectrometry. Deduce the isotopic composition of a sample of an element. Deduce the relative atomic mass of an element. Measure the relative molecular mass of a compound. Vaporization. The solid or liquid sample is vaporized into the gas phase. Ionization. High-energy electrons hit the atoms. This causes the atoms to lose 1 electron each, forming ions with a single positive charge. Acceleration. The ions are accelerated by an electric field. Deflection. The magnetic field causes the ions to change direction. Lighter ions are deflected more than heavy ions. Detection. Ions hit a metal plate which gives an electrical impulse. Allows the detector to detect ions of a particular mass. Vaporization. Ionization. Acceleration. Deflection. Detection. Learn where these components go in the diagram. A modern mass spectrometry machine. Mass spectrometry data. The data shows that the sample of neon has 3 isotopes. Mass spectrometry data. The data is represented in a graph. Identify carbon dioxide, propane, and cyclopropane on their respective graphs. Question. The naturally occurring isotopes of chlorine are shown in the table. Calculate the relative atomic mass of chlorine. Identify the different compounds and their respective components on the 3 graphs. Question. Calculate the relative atomic mass of magnesium from the following data. Uses of mass spectrometry. Radioactive dating. Space research. Sport. Pharmaceutical industry. Find out more about each of these. Thanks for watching. Like and subscribe.